I'm going to talk to you a little bit about something called renal clearance, which is to do with how much substance or how much of a particular substance will get extracted out of the plasma, get processed through the kidneys, and then actually be excreted out through the kidneys. So how much of a substance you clear, basically, from your body. Now, this is an area that people have difficulty with. You know, it's not really surprising, because it is quite a difficult concept. So what we'll do quickly here is we'll look here. Here's a Bowman's capsule. Okay, and here's the rest of your nephron, so a very basic structure of a nephron. And here is the blood supply. So we have glomerular capillary, afferent arterial, efferent arterial, and so on. And so what we have is, and we'll always think of the substance as substance X, and what we have is, for example, the plasma concentration, P of substance X, times V here, V of X, okay, within, or the flow rate, of the blood here in the glomerulus, and that's going to be equal to the excretion, urinary concentration of X times the volume of your urine. Okay, now really this value here is what we need to know. This is the clearance. And so what we normally do is we call this flow here, or this value in mils per minute, is the clearance value. And what we say is this value, the V dot of X, or the clearance of X, is going to be equal to the urine concentration of X multiplied the flow rate of your urine over the plasma concentration of substance X. That's what clearance is equal to. And so basically what you're doing is you're doing a modification of C1 times V1, where instead of having a volume, it's a rate of mil per minute, is equal to C2 V2. So here, concentration of urine, volume of urine. Here, concentration of substance X, volume of substance X, which is cleared in mils per minute. Because you're continuously flowing, you've got blood flow through there, the value is a rate and not a volume. So what we have here is the clearance. Let's make it simple. The clearance of substance X is equal to the urinary concentration of X times the flow rate over the plasma concentration of X. So what this value here, clearance, is actually equal to is it's telling us how much of the substance which is in the plasma will pass down through the kidney and actually be excreted by the kidney. Now let's use an example of different substances. Let's look, say for example, at a substance that is freely filtered, so it can freely enter the glomerulus, but is not reabsorbed or secreted. Now, if that substance is freely filtered, then that means that approximately 125 mils of that substance is going to enter the glomerulus every minute, and therefore all of it will end up being cleared. Why? Because it's not reabsorbed, so it won't get sucked back up into the blood, and none is secreted, so none will enter. So for that substance, your value of clearance would equal 125 mils per minute. Now, of course, this just sounds like I've made that up because I haven't gone through the calculations, and I'll do that in another part with regards to renal clearance. But it's just to give you an idea of what's going on. So basically what we're saying is here, when you look at this substance X in the glomerulus, what we have is we have substance X, and we have a certain amount. We have a plasma, say, volume of 750 mils going past the glomerulus every minute. And if we say we clear 125 mils of the substance X within it, what it basically means is that substance X is found dotted throughout that 750 mils. And the amount of substance X that is actually removed is equal to how much we'd find in 120 mils of the plasma. And that's what it stands for. Okay, so please have a look through that, basic concepts of it, and what we'll do next is we'll actually look at some particular substances to get you a bit of feeling for what clearance is actually equal to. Okay, thank you.